Hello. Am I audible?
Yes, sir.
Yes.
Yes, sir.
So, very good evening to all of you.
Good evening, sir.
So, so this is the open session for week 4. Meanwhile, all of you have covered the lectures, all the lecture video of week 4.
Yes, sir.
Yes, sir, most of it.
Okay. So you are able to understood the concepts. Mm.
Yes,
Relative
sir.
is column relative frequency, covariance, correlation, point biserial, and all things. Okay, so we will go week by, we will cover each activity, okay? We will cover in which do you doubt, just raise your hand and we'll discuss, okay? Let me share my screen. Second. My screen is visible to all of you?
Yes, sir.
Yes, sir.
Okay. So yeah, in this activity 4.2 or lecture related to this, anybody have any doubt in this activity and any concept related to this?
Sir, I had one doubt where to find the data which ma'am is using for making that Google spreadsheets, all the
Okay.
charts.
Okay, you can go there common data sets on the portal.
Sir, that data is not there. I checked.
I think
मैं
ma'am
ये
has
लोग हर दिन ऐसे वाला लाइव क्लास चलाना मेरे ध्यान से पूरा निकल गया था।
ma'am I think
लाइव क्लास हुआ
check
मैं सोचता था लाइव क्लास बिल्कुल हुई नहीं। ये हर दिन शाम को ये लोग लाइव क्लास का तो मेरा
Sahil, please mute yourself. Okay, you are on. Okay, so yeah, you can check. Otherwise, we'll check and let you know. Think ma'am has
Okay, sir, because it wasn't there in the common data set, I
no
checked.
worry about that. And just try to understand the concepts. Okay.
Yes, sir.
Okay. So any one of you have doubt in this activity or concept related in lecture 4.2, 4.1. So 4.1 just a review of the course and in lecture 4.2, any one of you have any doubt? It's about contingency table. Any difficulty in this first 3 questions?
No, sir.
Okay. You all are able to solve this, right?
Yes, sir.
Okay. In this 4, 5, and 6, any doubt? Here you have to just find the counts of the customers, right? What will be the answer for this? How many customers gave good rating in total for all fruits?
185.
185. Yeah, right. So similarly, you have to do for 5 and 6. So any difficulty in this activity?
So,
Okay. Okay, then let's move to the next activity. So any doubt in this activity or related to lecture video, I mean any concept in a lecture 4.3 or any doubt in this 4 question?
Number 3.
Question number
3.
okay, what is the percentage of customers who bought items after visiting these websites? Okay, so can you tell me first tell me what was your approach?
Yes, sir.
So yeah, please tell me.
Sir, I find the percentage of first website A in means
Mhm.
vis A website A, then website B, then website C.
So what was the answer?
My answer, is on sir, wrong 77%.
Okay, let's check. What is the correct answer? Should be
20,
20.
sir.
Okay, let's check. What is the
Yeah.
see? Question is, what is the percentage of customers who bought items after visiting these websites? Okay, so can you tell me what is the total number of customers who visit all the websites?
Okay. 6,500.
6,500. Okay,
Yeah.
so what will be the what is the grand total?
32,500.
So what will be the percentage?
Okay. Yes, sir.
Now you get it.
Yes, sir.
So
Sir,
let us
and question number 4 also.
in the question, what is the things first percentage of customer who bought items? Okay, so you have to consider the
Okay.
row of bought items after visiting these websites. That means A, B, and C. So total customers who visit all the website is 6,500, right? So you need to find the percentage. So 6,500 divided by this grand total into 100. Suppose question is, what percentage of customers who bought items after visiting the website A and B? Then what will be the answer? Then how many customers are there for after visiting the website A and B? It's 2,500. Okay.
Oh,
And in the fourth one, right? Does the
yes.
customer buying an item if he or she visits a website is associated with the e-commerce website? Does the customers buying an item, okay, if he or she visits a website is associated with the e-commerce website. Think uh, option, yeah, yes, more customers visiting a website buys an item. So more customers. So there is some mistake. Every company has similar frequencies. Continue. What is your exactly doubt in this one?
So I think according to my sir, B option B is correctly.
No,
A
every.
website have no more, sir.
I think I will. Okay, we'll check this one. I think option is something.
Sir, in the question 4, we are studying the relative frequency of all website A, B, and C.
Okay, okay. If you compute the row relative frequency for A, then it will be 1000 divided by, let's compute the row relative frequency. 1000 divided by 6,500. Okay. It will give you around, let me compute.
No, sir, 1000 divided by 3000.
Okay, this is the column relative frequency, right?
Yes, sir.
So
How
we
many
can,
people visit website A but don't buy it? And how many buy it? That's the frequency we have to find out.
no, no. Second, let me check this one. So if you compute for 1500 divided by 55 is 0.0.
0.27.
Okay, 4000 divided by 24,000. Okay, 0.17 is coming out to be this one. Okay,
Yes, sir.
okay, okay.
By
Does the
comparing A
customer
is
buying
much
an
more
item
than B.
before she visits a website? Oh, yeah. See, correct, correct. See, what is the question? Customer buying an item if he or she visits a website is associated with the e-commerce, right? Suppose if he visit the website A, right? So if you see, so 1000 divided by 3000 is how much? 0.33, right?
Yes, sir.
And
Yes.
Yes, sir.
for website B, what is the I mean relative frequency for a bought item? It will be 1500 divided by 5500, right?
Yeah,
So you will get
27.
how much? 0.27,
27.
right? For C, you
Yeah.
will get 4000 divided by 24,000, right?
Yes.
Are you getting my point? So here
Yeah.
you will get 0.17. So for website A, it's a 0.33, which is more, right? Is
Yes.
it clear, Pushpanjali, now?
Yes, sir.
Okay,
Firstly, we
anybody?
have to find the
Yes, yes,
percentage.
relative frequency. Yes, yes, yes.
Yeah.
Not about
Given
so
that.
yes. So how? Okay, what was that? Yeah. Anybody have any doubt in this activity or related to lecture video of this?
Sir, in this, how we identify it's talking about column frequency or it's talking about row frequency?
See, what is the does the customers buying an item? Okay, here we have to
Yeah.
consider the for bought item, right? When he visits a website, okay. So suppose he
Yeah.
visits the website A, that means this
Yeah.
column.
Yeah.
So what is the things for bought item 1000, right? He
Right.
visits the column B, okay. Then what is the
Yeah.
bought item 1500? He visits the
1500,
column C. What is the bought item 4000?
4000.
Okay. So, I
Yeah.
mean
Yes.
similarly, you have to think, right? Okay. Anything else? Any doubt in this activity or related to lecture video?
Excuse me, sir.
Yes, please.
Not related to this video, but then in the qualifier exam, will we be able to use Google
No,
spreadsheet,
no,
sir?
no. You can't use Google Sheet. There will you have to use only TCS scientific calculator. Okay. That is the simple.
Yes, sir, thank
Yeah. Okay. So anybody have any doubt in this activity? Shahid has
Sir,
raised hand.
in
Sir,
first
pardon me.
question,
Allow me, sir.
Yes.
Can I? So I have a query about this thing. Like we have to go through the like first 4 weeks of contents and learn more things about it, and those will be facing the exam from those things, right? Not the fifth week, right?
Yes. Yes. You have to. I mean, in qualifier exam, syllabus is only up to week 4.
Only week 4, and for the 50% for the to appear in the qualifier, we have to ensure that we are getting at least 50+% out of these
See,
four
Shahid,
weeks.
see, such type of things you can go through first. Go through the grading pattern. What is the criteria for such type of things? First thing, and rest of the things you can. If it's not there, you can write it supporting.
Got it. Thank
Okay.
you.
Yeah. Because see, we are here for this week 4 discussion. Okay. Yeah.
sir,
So
sir, just a minute, just a first question. What is the relative frequency? Okay, here relative in second question.
see
Oh,
what.
what is the second question, sir?
Okay.
Uh,
What percentage of bought items were from C? So it's
C
simple.
given.
So it is asking about what percentage of bought item. That means you have to consider the bought item total, right? Out
Okay.
in these row, what is the
Yeah.
percentage? I mean that item is from website C. That means
Yeah.
4000 divided by 6500, right?
Okay.
Are you getting?
4000 divided by 6500. But in first question is directly talking about relative, but in second question it's not talking about relative. Basically, I have confused here sometime where we count, take it as a column frequency or what time I take it's a row relative frequency. Any difference in the language, like how to identify it?
No, see if it is see 1 second. If it is about like percentage and all things, right? See, first thing it will be mentioned like relative frequency,
Yeah.
percentage, proportion, and all things, right? If it's
Yes.
only about frequency, then it will ask you like what is the how many customers or what is the number, right? Like in this activity, if you can see. So here it is question about how many customers. It's not asking about relative frequency. Okay. So relative
Yeah.
frequency is about you can say in form of proportion and all things, right?
Right.
Okay. So similarly, you have to do. So it will be clear. No, see, if you do or see what the thing, you have to be focused on the statement. That's it. Suppose in this first, how will you approach? What is the relative frequency of bought items corresponding to website A?
Okay.
So what will be the answer?
1000 divided by 6500.
Kindly read the question again. What is
Relative
the
frequency.
relative
What is the
frequency of bought items corresponding to website A?
website? 1000, 1500 plus 4000 divided by 6500. Just bought item in website A, 1000 divided by 6500.
It's not about, see, okay, 1000 divided by 6500. So
Yes,
according to you, answer should be 0.15, right?
yes, sir.
That's its answer. So answer is 0.33. What is the question? See,
Yeah.
what is the relative frequency of bought items corresponding to website A? So corresponding to website A, right? What is the
Yeah.
relative frequency of bought item? That means corresponding to website A, there are 3000 items, out of which 1000 are bought, 2000 did not buy, right? So 1000 divided by 3000. It not see, question is not about what percentage of bought items are from were from website A. Okay,
Okay.
try to differentiate between first question and second question. Just in the second question, just replace it with A. You will get the
A.
difference between these two, right?
Yes, sir. I will analyze this
Yeah,
question.
yeah. Just
Yeah.
okay.
Just,
Anybody else?
yeah.
Any doubt in this activity or in lecture 4.3? Okay. Do you have any doubt? Anybody? Hello.
No, sir.
No, right? Is it for everyone?
Yes, sir.
So okay. Yeah. So can you tell me in the lecture 4.3? Things are discussed like association between two categorical variables. Okay. So can you tell me what is the criteria when two categorical variables are associated?
Linear relationship.
Ravi, right?
Yeah.
Yeah, I'm only
So
taking a chance.
no. See. Can you find the linear relationship for categorical variables? I'm asking.
No. No.
I'm asking what is the criteria to find two categorical variables are associated?
Four criteria, sir. One is
Sir,
direction.
if the percentage of rows or columns are equal to
Yes.
or same.
Not
You have to go. I mean, you have to consider the
Contingency table.
contingency
contingency
table.
table.
Okay.
Yeah.
What is the things in the contingency table? Suppose I have gender. Okay. Suppose two, female and male. Okay. And there is another categorical variable. Let's say ownership of phone. I mean, I'm taking the example of ma'am. So there is something who do not own a phone and own a phone, right? So suppose this is number A, this is number B, this is number C, this is number D. Okay, I mean there are A female who do not own a phone and B female who own a phone. Okay, C who do not own a phone and D who own a phone, right? So this is the row total. That means A plus B, C plus D, right? And this is the column total. It will be A plus C and B plus D, and this will be grand total A plus B plus C plus. Is it clear now till this point?
Yes, sir.
Okay. So how will you find the row relative frequency?
A upon A plus B.
A
A upon
upon
A
A
plus
plus
A
B.
plus
Suppose
B.
I want to change it in percentage, then I have to multiply
Multiply
by
100.
100. Okay.
100.
So it will be B by A plus B into
100.
100, C plus C by D into 100,
100.
and D by D plus or C plus D into 100. Similarly, I can do for last column as well. That means A plus C divided by A plus B plus C plus D into 100, and B plus D divided by A plus B plus C plus D into 100. Is it clear? Suppose these are the row relative frequencies. So what is the criteria? If all the row relative frequencies are same, then categorical variables
Not associated.
are not
So,
associated. Okay.
sir,
Similarly, I can find
I
by the column relative frequency as well, right? So
yeah.
anyone you can use. Either you can go with the row relative frequency, or you can compute with the column relative frequency. Okay. And suppose all the row relative frequencies are not same. Okay. Then variables are
Tightly
Associated.
associated.
Variables are associated, right?
Associated.
Sir,
So,
one question. Sorry to interrupt. Can I
mhm,
say?
mhm.
Sir, why if percentage is same, suppose a
Okay, okay.
upon a plus b
I will.
percentage is equal to a plus b percentage, both are equal, then why it is not associated? Suppose uh, one shop has 100 mobile and it sell 100 mobile. Suppose I have 100 cell phone and uh, I sell all 100 phone to all customer.
Okay, okay.
So,
Omkar, Om Sharma. Can you tell me, see, have you read the stacked bar chart?
yes, sir.
Okay. Suppose this is the female and this is the male.
Yeah,
I'm going to for 100% stacked bar chart list.
yeah,
Or you can say stacked bar chart list. Or 100%. You can say. Yeah, 100% list.
yeah.
Suppose this is the 0%, this is 10%, 20%, 30, and so on. This is suppose 100%.
100.
Okay. Okay.
Yeah.
So for female, that's why I asked any doubt in the lecture video. So no one of you responded. Please respond. Okay. This session for you. Okay. So suppose, yeah, let's say suppose all the things are one second, let me change the color. Suppose this is the system.
I divided in two parts, basically multi.
So that is the stacked bar chart, right? See, bar
Yeah,
chart is
yeah.
something count, and the stacked bar chart is we are, I mean, divided our
Differentiate.
bar some segment, okay, into segment, and 100% is here we are interested in the percentage, not in the count, right? So
Yeah,
suppose
right.
this suppose green region for owning a phone and a red region is for not owning a phone. Okay,
Okay.
can you tell me what is the meaning of association? I mean, I can say
Association.
change in one variable gives information for the change in another variable.
Another. Yes.
So here, if you see, I'm going to change in the one variable. I mean, in gender,
Yeah.
is there things? Is there change in a second variable? No. Green
No.
region is approximately same as the this green region, and this red region is approximately same as this red region.
Mm.
So that means variables are not associated.
Associated.
Okay. If
Okay.
change in one variable gives you information that yeah, there is happening change in another variable, that means variables are associated. Okay. Are you
Okay,
getting my
sir.
point, Omkar? Om Sharma?
Yes, sir. I got it.
Hmm?
Just can I say, explain in Hindi? Basically, I think I understand. Uh,
See. What is the thing? Association. Association is change in one variable. Okay. So this is the one variable gender, right? This is the another variable which is ownership. Okay.
okay. Now, just suppose I have 100 phone. That means 100%.
Hmm.
75% male bought the phone and 25% female bought the phone. That means here, if I increase the female percentage, suppose 35% female bought the
Hmm.
phone, that means here 10% I decrease and 65% male bought the phone.
Hmm.
We will basically uh, how can
So here you are
just
not mentioning
increasing
about
or decreasing the
one
percentage
second.
in.
1 second, Om. You are here. You are not mentioning the percentage of who do not own a phone. Okay. So you have to consider both things.
Okay,
Repeating my points.
okay, sir.
Okay. So
Okay, sir.
suppose this is about, let's say this is about 74%, and this is
Yes,
let's about 26%. Okay. Suppose this
yes,
is the 74 point, let's say 63%, and this is suppose uh, what it will be 25.37% if I'm not wrong.
yeah,
So if you see things are approximately same, I mean there is no big change when you are considering the change in one variable, right? If
yeah,
considering the change in one variable will show the change in another variable, that means things are associated, right? But here things are same. That means
same.
variables are not associated.
Oh,
Similarly, you can we are computing by the mathematically here. Okay.
Okay. Okay, sir.
And so suppose here if you draw, okay, suppose this is the female, this is the male. Okay, suppose this is the male and male both sides. Okay, for the female, this is the green region for male. Okay. This one. Okay, so green region for owning a phone and red region for not owning a phone. So in this 100% stacked bar chart,
Yeah.
I mean, if you see, red region is not approximately same as the this red region, right? Similarly for
Correct.
green region. Okay, so that
Yes, sir.
means variables are not associated.
Not this.
Okay,
Okay, sir.
so anybody else have doubt in this activity or in this lecture video or any concept? So you have doubt, so you can ask. Otherwise, we will move to the next activity and next lecture video.
Sir, association means that how they both variables are related to each other.
Yes, yes, that's the simple things. How they are
Yes, sir.
associated, how they are related to each other, right? That means
Sir, I have a doubt in gradient
knowing
descending.
information in one variable gives you the information about another variable. Yes, please go ahead.
Sir, I have a doubt in gradient descending week 3, question number 3.
I think we are going to, I mean, we are going in sequence. After that, we will discuss it. Okay.
Okay, sir.
Yeah. So that, all the concepts should cover. That's why I'm going to I mean, lecture by lecture video. Okay. So should I move to lecture, I mean, activity 4.4?
Sir,
Yes, please.
sir, for checking whether it is a association or not,
Associated, no? Yes, yes.
yes, we have to check both column and row.
No, no, no. Anything you can do. Either you can compute row relative frequency or column relative frequency. No need to compute both. Just compute row relative frequency or column relative frequency. If all the row relative frequencies are same for all the row, that means variables are not associated. If relative frequencies are different in some row or I mean, are not same for all the rows, that means variables are associated. Similarly, you can consider for the column relative frequency. Okay, I mean, any thing you can use. Either you can use the row relative frequency or you can use the column relative frequency. Okay.
Okay, sir.
Yeah. So should I move to the next? Yeah. So any one of you have doubt in lecture 4.4, any concept or and any doubt in this activity? So you can ask. We'll discuss. Hello. Hello.
Yes,
Am I
sir.
audible, right? Yeah. Am I audible, right?
Yes, sir.
Yeah, yeah. So
Yes,
who
sir.
has doubt
Yes, sir.
in this? Any one of you, if you have doubt in activity 4.4 or any concept related to lecture 4.4, so you can ask.
Sir, small doubt.
Yeah, yes, please. Mhm.
How do we identify that whether there is an outlier in a scatter plot or not?
Yeah, it's see, what is the outlier? What is the meaning of outlier?
That I according to me it's I think it's beyond the range, I think.
That's simple. Outlier in a scatter plot, you can say, is the point, or it can be a single point or some more points that are farthest from the regression line. Okay,
Okay,
like
sir.
that. Okay, suppose one second.
Hello.
Suppose this is the my x-axis, this is my y-axis. Okay. Suppose these are the some observations. Okay.
Yes, sir.
and these are on the close to the regression line. Okay, outlier will be which is farthest from the regression line. Like this you can consider as an outlier. This point you can consider as an. That's it. Okay.
Okay, sir. Thank you, sir.
Yeah. So anyone of you know, are you about what is the suppose the variable which I can plot on the x-axis that is called this is also called explanatory
Explanatory
variable.
variable.
Okay, that means there is another name for this independent variable. Okay,
Yes, sir.
and the variable on the y-axis is called the response
Dependent
variable.
Response variable.
Response
responsive.
variable.
And or you can say dependent variable.
Dependent.
Okay, is it clear? Okay, suppose yeah, I'm asking a question. Suppose can you tell me suppose after plotting the data I got such type of scatter plot, then what inference you can draw here? I mean, what can you
Linear.
say? Okay, variables are linearly associated. Okay, and is this positive or negative?
Positive.
Positive, because
Pure
increasing in x
positive.
also increasing in y
Y.
here. Okay, okay. Suppose the things are change here, like this is x, this is the y. Suppose on after plotting I get it like that. Then what is this linearly associated or not?
It is linearly associated but negative
Negative. Okay, because increasing
because
in
x is
x, y
increasing,
is decreasing.
decreasing.
Yeah, correct. Okay, so yeah. Okay, anyone how anybody have anyone of you have doubt in this activity or a lecture in this lecture 4.4?
Sir, hello.
Yes, please. Yes, Prachi.
Sir, in question number one, the explanatory variable is what? Age in years.
Okay, yes, because see, age in years you can plot on x-axis and IQ you can say something. It might depend on the age, right? Like suppose 1 year child. Okay, I mean it can be like I mean IQ score might depend on the age, right? Age cannot depend on the IQ score.
Okay, sir.
Okay, anybody else? All the doubts are have cleared, right? I think you are not asking any doubts.
Sir,
Yes.
will weight be a response variable compared to height? I mean, like a how we understand height, that as age increases, height increases.
So it depends on what variables you are considering. What are your two variables, right? Both variables. Suppose
No, no,
weight.
like suppose
Yes.
you have, like one example you have age and height, other example
Okay.
you have got age and weight. So is weight the response variable?
Age accordingly, yes, you can consider, right? I mean, it might be weight can depend on age. It might depend, right? Suppose weight of a 10 years child might be less than weight of suppose he when he will be on 15 years. So it might weight can increase. Okay. So you have to think which
So,
can depend on the another variable.
so we always say that height will increase, but weight can always go up and down. So still it is okay, no, as a response variable, like on y-axis.
Okay, see, what is the thing, Ravi? See, you have to just think which can depend on the second variable or not,
Ah,
right?
okay, okay. That
Okay,
way. Ah, yes, got it, got it.
yeah. So in this activity or in lecture 4.5, any one of you have any doubt in
No,
this
from my side.
question number one? What is the answer? What should be the answer?
Curve is trending downward.
Curve is trending.
Downward.
Okay, so that is the okay. You said that this is the correct answer. And in this second question,
Linear, sir.
scatter plot is
Linear outline.
outliers is there.
And no
No, no,
outlier.
no,
First and last.
Okay,
First and last.
in this
Both option also.
okay, first and last. Okay,
Yes, sir.
Yeah, because this is the multiple select question. Okay,
Yeah.
we'll check the answer up to this. Okay, for this
Curve
third question,
Trending
curve is
upward.
trending
Is
upward
trending
and
upward. No outliers.
scatter plot linear.
Scatter plot appears to
No
be
outlier.
Last option.
okay. And about what
Sir, the
about this?
Outliers.
Point
Linear.
outliers.
so sir, that curve
So
is
outliers and
Linear.
linear.
Second option, sir.
Okay,
Scatter plots
And
as an
last.
outlier.
And
Second
outlier.
last.
Okay, last.
okay, let's check.
Why
Hello?
Or it's the
no, sir, no, sir.
mhm.
Hello,
tightly,
sir,
Yes,
in
yes.
question number.
Tightly custard.
tightly.
sir.
Sir,
Okay, we'll
before
check.
that,
Yeah,
Sir,
Sir,
please
in
go to the previous question, sir.
yeah, one by one, please, one by one. Yes, yeah.
Sir, why the scatter
the
plot
plot
does
appears to
not
be
have?
curved. Option
Yeah,
number 4 should
yeah,
also
yeah.
be correct.
Okay,
yes, sir. Same doubt.
Yes, sir.
okay, okay.
Same.
Let's check the
Yeah.
see what you are saying. I was just clicking.
Sir, first
Okay, yeah, this is the correct. Someone is
Yes, sir.
somewhere is wrong. This is also
first
correct
first
because
one.
see,
First
curve is
one.
trending
First
There are no
upward
outliers.
and scatter plot is see here.
Correct.
See here, it's a curve is upward, but it's not kind of linear, right? And
Yeah.
it does not outliers also. The second is also correct because
Correct.
scatter plot is linear and it does not have any outliers. Okay, so here
No outliers.
we have to
Last.
also select
Scatter
that
plot does
this
not have.
also
Yes, sir.
scatter plot does not have outliers. Okay, because it's a something curve is trending downwards.
Yeah.
Okay, is it clear? Any
Yes.
doubt in anybody?
No, sir. Clear.
Yes.
Okay,
So,
let's
sir,
move to the
I have one question now. So, with
yeah.
respect to outliers, earlier we had learned about Q3, Q1, and IQR. Is it related to same concept here also in outliers?
See, what is the outliers? Outliers is something which is farthest from your data set, right? Which is not in the normal thing. So
Yeah.
from the scatter plot, it's a quick idea to find the, yeah, it is the outlier. Outlier is the same things for any data set, right? Similarly, see, in box plot, how you can find the outliers? Suppose this is the box plot, this is the minimum, this is the maximum, right? This is the Q3, this is the Q1. The outlier is something which is here, which is here.
Yes.
So which is
Yes.
not in the your which is farthest from your I mean data set, you can say normal
Okay.
data set. Okay.
But only in this section we're talking about scatter plot. In that section we were
Yeah, it's
talking
in
about.
scatter plot. Similarly, which the observation which are farthest from your regressor line will be the will consider as a outlier.
Sure. Thank you.
Okay, let's move to the see. Yeah, any doubt in this activity or related to the lecture 4.6? Okay, let's go one by one. So in the first question, covariance between two variables is negative when
Opposite direction. Both move in
Opposite
opposite.
direction. Opposite
Both
direction.
in opposite.
both move in the opposite direction.
Yes, sir.
Okay, let's see. So in the second question, unit of covariance of two variables, if one of the variable is
Third
measured
and
in
fourth.
kilogram
Third and fourth.
and other is
Kilometer.
meter is
Kilo,
Meter.
kilogram, meter into kilogram.
Yeah.
Third and
third and fourth. Okay. What? Yeah. Okay. So what is the
39.
sample covariance for this?
39.
39.
39.
9.
Okay. Let's check the answer from your side. Yeah. So correct answer. Okay. See. You know covariance between the two variables is negative when both moves in the opposite direction. The meaning of this one.
One is positive, one is a negative.
Okay, yes, because moving in the see, if he moving the same direction means both can move. I mean, both can be decreasing, right?
Yeah.
Yeah. Let's. I'm
Can we
drawing.
say, sir, can we say that the deviation between both of them is either negative?
Yes, yes. Let me. I'm going to draw this. You can visualize very clearly. Suppose this is my x and this is the my y. Okay. You know, in the covariance formula, you have 1 upon n. I'm writing the formula population covariance summation xi minus x bar and yi minus y bar, right? This is thing. Okay. So suppose this is the my x bar here. This is my y bar here. Okay. Let's assume. So suppose this is the y bar and this is the x bar. Is it clear now? Okay.
Yes, sir.
And what is suppose points are going to like this. Okay. Suppose your points is some linear and all things, whatever. just forget about points. Okay. Okay, let's say do not consider the points for now. Let's try to understand the what I'm going to here. Yeah. So for this region, xi minus x bar will be what? Less than 0 or greater than 0?
Less than 0.
Less than.
Less than 0. Everyone is getting this?
Yes, sir.
Okay. For this region, yi minus y bar will be what?
0, less than 0.
Less than 0. Because why this? Y bar is this. Okay. This is the x bar. Is we are considering the left side of this. And for this region, xi minus x bar will be
Positive.
positive.
Negative.
And yi minus y bar will be
Less than 0.
Negative.
negative. For this region,
Both
xi
positive.
minus x bar will be
Positive.
yi minus y bar will be
Positive.
for this region,
Xi
xi
minus
minus x bar will be
negative.
Negative.
and yi minus y bar will be
Positive.
Positive.
positive, right? So
Yes.
product of these two will be what here? Positive or negative? Product of xi
Like
minus x bar and yi minus y bar.
Positive, sir.
Positive, because see, multiplication of two negative quantities will give you the value in the positive, right? Is it clear? For this region, product will be negative.
negative.
See, if you multiplied minus 2 and positive 2, it will give you minus 4, right? Are you getting my point? Because
sir.
one quantity is less than 0, one quantity is greater than 0. And for this region, product will be,
Positive.
Positive.
and for this,
It's negative.
Negative.
so did you, now it's clear when it will be positive and negative.
Yes, sir.
Okay. So, and similarly, you can interpret for the correlation as well, because correlation coefficient is depend on the covariance. Okay, because correlation is what? Covariance between x comma y divided by standard deviation of x into standard deviation of y, right? So depending on the this, because standard deviation is always positive.
Positive, yes.
Okay, so it depends on the covariance also. So both I mean the things will be same in both cases. Is it clear for everyone?
Yes, sir.
Okay, so can you tell me what is the role of covariance?
How data varied.
What covariance quantifies us? Basically, it tells us the linear association between two numerical variables, right?
Yes, sir.
Okay.
Yes,
And
sir.
there are two formula for the covariance. One is the population covariance, this is, and one is the sample covariance.
Sample.
So it will be 1 upon n
N
minus
minus
1
1.
summation xi minus x bar into yi
N
minus,
minus y bar.
okay, this is the, yeah. So
Sir,
any doubt in this lecture video, I mean lecture 4.6 or activity 4.6?
sir,
Yes, please.
just a general doubt.
Mhm.
In the sample covariance and population covariance, we are
Mhm.
using X bar and Y bar. So
Mhm.
are they correspondingly sample mean or
Yes, yes, it's the mean of your data set. That's it.
and one more thing,
Mhm.
when we are given with a table and all the data are there, then
Mhm.
why are we just talking about sample mean and sample covariance most of the time? And why are you not considering population mean, even if the whole table is there? And
No, no, it's not about whole table. Where we have considered that. See, in see, what is the population mean? Suppose you have whole data set, right? So population
yes,
mean
sir.
will be sum of all the observation divided by total number of observation. And suppose you have sample data, okay? Then sum of all the observation divided by number of observation. That's about the mean. Okay. Here we are considering the x bar and y bar. It's nothing but the mean of the data set. That's it. You have to add all the observations and divide by number of observations. Okay.
Uh,
And for the population covariance, you have to divide by n, and for the sample covariance, you have to divide by n minus. Is
okay,
it
sir.
clear?
Thank you.
Yeah.
Yes, sir.
So anybody else have any doubt, or should we move to the next? If you have doubt, then we can discuss here.
Sir, in real world, how to use it, this correlation and all this thing?
See, can you tell me what is the role of variance? It tells you the basically
Very
variability of your data sets from its mean, right?
right.
And in the covariance, it tells us basically what is the linear association between two numerical variables. Or you can also consider the covariance as covariance is between two variables and variance is for the one variable. Okay, let me clarify this one. See, suppose covariance between x comma y is what? Nothing but 1 upon n summation of xi minus x bar,
X bar.
yi minus y bar,
Y bar.
right?
Yes. Right.
Suppose I am saying, tell me covariance of x. It means summation of xi minus x bar into xi minus x bar.
Yes.
So it will be 1 upon n summation xi minus x bar.
All this. To X.
Okay. So this is for the two variables and this is for the one variable.
One
In
variable.
real problem, see, in real world problem, so covariance will tell you basically linear association between two variables, right? Like here we have discussed, right? So whether the see,
It's
suppose
it's
one variable is okay,
increasing trend, downward trend.
yeah,
Basically, we
second is
analyze the
decreasing.
chart. Basically.
Yes, you can say what is the linear association between these two. So yeah,
Okay.
since see covariance is something, if you see covariance, suppose this is the age, okay, this is the weight of the data and this is the age of data. So covariance in the final you will get in year into kilogram, okay.
Yes.
See, final answer you will get in the units, okay.
Yeah.
Now that's why correlation comes into the
Hello.
I think.
Hello.
No, I think we lost the audio of Prashant. Am I audible?
Yes.
Okay. So let me fill in that answer to the question. Om Sharma, right? You asked the real word.
Yeah. Yes.
Yeah, right. Now look at what we're doing today.
Okay.
Let's say that, we want to understand whether the participation
hello, am I
in
audible?
the life.
Yes.
Yeah.
Yes.
Prashant, I'm just giving a real world, scenario where we
Okay.
use a
Yeah,
covariance.
yes, yes,
If that's
yes,
fine
yes.
with you, all right?
Okay, yeah.
So
Please go ahead.
let's say that, we are looking at whether participation in the live classes,
Okay.
is it impacting, the percentage of pass in the qualifiers? I'm just giving a kind of hypothetical situation. Okay.
Okay.
So
Okay.
one variable is the participation in the live classes. All right.
Okay.
Now
Right.
the other variable is the performance, the past performance in the
Yeah,
qualifiers.
yeah, correct.
Correct.
Now, if I can see that as independently, I can compute the variance separately for the pass percentage in qualifiers. That is how good or bad the students are passing. The second variable is about what do you call it?
Participant.
What is the participation rate? Okay.
Yeah. Right.
So now, if I want to understand whether, what do you call it, there is a relationship between these two, okay, we
Okay.
naturally we expect a higher participation to lead to a better pass rate, right, Om Sharma?
Right.
But that needs to be validated, and that is where we bring in the covariance. If we, I hope that this is adding some clarity, a real world clarity.
Yes.
Correct,
Yes.
correct.
Okay.
And
Go ahead, Prashant.
one more example similar to this, you can take. Thanks, Ajay.
Yeah.
You can take like one variable as let's take. You can say student. You can say student spends time. Okay.
Yeah.
On watching TV, right?
Yes.
Okay. And another variable you can take their exam score. Okay, so you can find the correlation between these two variables.
No.
Why cannot? Why cannot you find?
Maybe fine.
No, you can find. See,
Fine.
here suppose students watching. Okay, student is spending more time on watching the TV during
Maybe
the exam period, and
exam
their
period.
exam score might be correlated.
Yes, might be.
Okay, so you can find. I mean, you have to think whether yeah. So what correlation tells you basically, and basically you can say change. Suppose x is increasing, okay, and y is decreasing. Then what the correlation you will get? I mean, between these two variable, you can get as a negative correlation.
Okay. Yes.
Are you getting my point?
Got it. Got it.
Got it. Similarly, here see, you can interpret from this chart. Suppose your x is increasing and y is also increasing,
Encouraging.
right?
Right.
Like the as the example give the example. Suppose live session attendance in the live session and marks in qualifier exam. Okay,
Qualifier exam.
so
Yes.
well, suppose the more number of live session you have attended, okay, it
Yes.
might be related. Yeah, you are able to qualify the exam, or you get the
Exam.
more marks in the qualify exam.
Yes. It's
Okay, it
dependent.
can be in
Yes.
reverse order also.
Yeah.
Okay, yeah.
Okay.
I was at the point for the unitless measure. So suppose covariance is coming out to be in year and kilogram. Okay, so
Yes.
Sx x is the year. So as unit of this Sx will be year also,
Yes.
and is unit of Sy will be in kilogram.
Kilogram.
So both gets cancel out. So correlation
Yes.
is basically unitless measure. Okay,
Yes. Yes.
that's a difference. Is it clear? And
Yes.
there are two formulas for the correlation coefficient. See, correlation is nothing but the you can find covariance of x comma y into sx into sy. See, if you are
That's
using
why.
the sample standard deviation, be careful. You have to use the sample correlation,
Correlation.
because that only then you will get this formula. There is another this formula also for the correlation coefficient. Okay, summation
Yes.
xi minus x bar into yi minus y bar is square root of summation xi minus x bar
X
square into square root of summation yi minus y bar square. So this formula you will get only when this should be the sample correlation, sample covariance when it is sample standard deviation. Why? See, suppose I'm using 1 upon n minus 1 summation xi minus x bar yi minus y bar, right?
right.
So Sx is what? Square root of 1 upon n minus 1 sample, I mean summation xi minus x bar square. Similarly, square root of 1 upon n minus 1 summation yi minus y bar square. Okay. So this 1 upon n minus 1, if you take outside the square root, we'll get by this quantity. So remaining things are same for as this. Okay.
Yes.
So see, so, sometimes students make mistake. They compute the for the denominator standard deviation for x and y respectively, but by mistakenly they compute the covariance for by dividing 1 upon n. No, so be careful. If you are using 1 upon n, I mean you are using the population covariance formula here, then you have to compute the population standard deviation as well. Is it clear? Because if you
Yeah.
will use the population standard deviation, that means this quantity. Okay, so 1 upon n summation yi minus y bar square. So this 1 upon n will get cancelled out by this both 1 upon n. So again you will get the this quantity, okay, which is this. So be careful. If you are using the sample standard deviations, then please use the sample covariance formula. If you are using the population standard deviation, then use population covariance formula, or just simply use the this formula. Okay, or a simple for simplicity you can use it. Is it clear?
Yes. Clear.
Okay,
Sir,
so
could you please tell us what is the difference between the deviation and variance?
deviation and variance.
Yes, sir.
Okay, so can you tell me what is we have read about the measures of dispersion. Okay,
Yes.
what are those?
One is interquartile range, I think.
Hmm? What are those?
So range, variance, standard deviation.
Range,
Standard deviation.
Variance,
variance, and standard.
standard deviation.
So this is the part of this one. I mean, deviation is what? Standard deviation is what? Just you have to this.
So
I mean,
square
this is
root
the
of the
measure of
variance,
that.
right?
Yeah, that is the things. What I'm saying, this is the measure of. I mean, measure of the dispersion, right? And what is
Yeah.
the meaning of dispersion? You can say
How data is to be
how data are
So
separate
the variation of the
spread.
data, right?
variation is there, right?
Yeah.
So deviation is nothing but you can simply say it's the slightly can say diverge something. There is some variation. There is some scatteredness in the data set. Kalyani, are you getting?
Yes, sir. And sir, the data, how much data is scattered from the mean? That is a
That
standard
is the your
deviation.
standard deviation or variance also. Okay, so basically standard deviation gives you the things. I mean, it is the standard deviation is nothing but the square root of the your variance. Okay, but the formula is same. If you see 1 upon n summation of xi minus x bar square, that means deviation from the mean. I mean, deviation for all the observation from its mean. Okay.
Okay, sir. I got this. How
Mm-hmm.
is means standard deviation is how data is separated from the mean position. But in
Yes,
case
yes.
of variance, if we can see like there is a square root means square root. So
Mm-hmm.
what is the actual application of the variance and standard deviation? So where we have to use standard
Okay.
deviation and where we have to use the variance.
Okay, okay. I'm going to tell. What is the variance? Okay, before any one of you wants to tell her if you are aware about this,
1 upon n summation of xi minus x bar square.
and what will be the standard deviation for this,
A square root of variance.
right?
Yes.
Now, suppose X is the data of weight of some person, okay? So the variance you will get in kilogram square,
Yes, sir.
correct?
Yes.
And the standard deviation you will get suppose square root of the kilogram square, that means you will get the standard deviation in kilogram.
Kilogram. Yes.
So that means we use the standard deviation because the standard deviation gives the value for in your original unit of your data set, right? So it's easy to interpret about our data set because it gives the things in original units of our original data set. Here units are changed. Is it clear?
Yes, sir. Yeah. And sir, can I ask one more question?
Is it from 4.6? I mean, this related because we are going in sequence. That's why I'm
Yeah, yeah,
trying
yeah.
to.
Sure, 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 sure. Please
Yeah.
go ahead.
Okay.
Yeah.
So any doubt? Yeah, let's move to the next. Okay. So any one of you have any doubt related to this activity and or related to this lecture 4.7? Any concept related doubt or any this activity doubt? Hello. Okay, so tell me, what is the correct option for the first question? Choose the wrong options among the following.
Correlation is a measure of
First one is
linear
wrong.
association.
The first one is wrong.
Okay. And after that?
Third one is also wrong.
Yes, sir.
Okay.
It's really good. And fourth one is wrong, I guess.
Fourth one is?
Fourth one is
Fourth one
also
is
wrong, I
wrong.
guess.
Okay.
I need to
Okay.
read that
Because
first.
it must be positive.
Okay. Choose the correct options about the values taken by correlation coefficient. So which are, which is the correct option?
Third one, sir.
Second.
Third one,
Third
sir.
one.
Third one. Third.
Third one.
Okay. And
Third.
in this third question,
Sir, second and third one.
Third and second.
in the fourth,
Weak and negative.
First one, sir.
Strong and negative.
okay. And the fifth,
Even positive. Okay.
it's the second, because I told you guys, if you see, correlation is depend on the covariance, right?
Yes.
In form of, because in form of positivity and negativity, because standard deviation is always positive, right? So that means correlation is directly depend on the covariance. Okay. So read this one.
So in that case, the first one would be also an option. Cannot take negative values. If
Cannot
the
take negative.
yeah, if the covariance of two variables is positive, then the correlation coefficient has to be positive. So it
Okay,
cannot take
okay.
any negative values.
Okay, we'll check. Yeah, in the sixth one, you have to just apply the, sample covariance is given to you and sample variance is given to you for X, sample variance for Y, and you have to compute the sample correlation. Let's check the answers for the remaining questions. Okay. So, yes. So this is the correct. See, covariance between two variables is positive. That means correlation is also positive. Positive means it cannot take the negative values, right? Because if you see, covariance is positive for this case and for this case. Okay. If covariance positive, you can see in the formula of correlation, covariance between x comma y divided by sx into sy, right? That means what?
Yes.
Summation of xi minus x bar, yi minus y bar divided by square root of summation of xi minus x bar square into square root of summation yi minus y bar square. So this is always greater than 0. This is always greater than 0. That means correlation is depend on the this quantity. If this quantity is greater than 0, that means correlation is positive. If this quantity is less than 0, then correlation is negative. Is this clear?
Clear.
Okay, nice. Yeah. So similarly, see, here it will be strong and negative. There are some ranges. You are aware about that when it will be strong and positive, strong and negative.
So 0.75 to 1, it's strong.
Okay.
0.5 to 0.75, it's
Moderate and
moderate. And
yeah.
like the negative and positive,
Yes,
we
yes.
can just consider, right?
Consider,
So
yes.
so
So,
0.25 to 5 is weak, and 0 to 0.25 is no association.
so should I write or everyone is aware about it? You can, if you want, then I can write. Yeah, let me write it down so that if it's like that, okay, that means strong and
Strong and positive.
positive. Strong and positive linear relationship. Okay. Second is suppose it's 0.5 to before 0.75. Okay, that means moderate and
Positive.
positive. Is it clear? Now suppose it's 0.25 to before 0.5, that means weak and positive.
Yeah.
Okay, you can say next one is minus 0.25 to 0.25. It will be absence of linear relationship, right?
Yeah.
And next will be minus 0.5 to minus 0.25, weak and negative.
Yeah.
Okay. and next will be minus 0.75 to 0. Sorry, minus 0.5. That means moderate and
Negative.
negative. Okay, and last will be uh, strong and
Strong and negative.
so you can take the screenshot here for the further use. Okay, so just take and inform me.
So just a small question over here.
Yes, sir.
Uh, so we are taking for the second option, we are taking I mean not second option, I mean the second line you have written. We are
Mm-hmm.
including the 0.5
Mm-hmm.
and we are excluding the 0.75.
Mm-hmm.
So is that's the reason, because if the value for any arbitrary value or anything, if it's
Mm-hmm.
0.75, that means we are
Strong.
including that into the first category, right?
Yes, yes, strong and positive.
So same for the if I have 0.5, so it's
That means
getting on the
moderate.
moderate, right?
Yes, yes, yes.
Okay, thank you.
So
Sir, is
clear
this
the
equality is strict? Means does it matter that if R is
yeah, you can say it's a
0.5,
matter. Yeah, it's kind of matter because it's we have written this from the ma'am has told from the ma'am has drawn a linear line and
sir, but
we have written
if
from
we
this. Yes.
apply a little, means if there is 0.5, then we can also
Yeah, you
say
can
it is
say
weak.
no, no. See, just a moderate because 0.5 is what? It's a middle point kind of things, right? For the 0 to 1, R is something minus 1 to 1, right? Okay.
Okay, so we have to strictly follow this
Yeah, you
notation, right,
can. Yeah,
sir?
for now you can just take it. It's not kind of universal. Yeah, but it's for a idea whether it's moderate and weak and okay, or more strong and all this. Okay. So any doubt in lecture 4.7 or in activity 4.7?
No, sir.
Okay. So
Sir.
let's move to the next activity. Any doubt in this activity 4.8 something or any concept related in 4.8?
Sir, actually 4.8 talks about the significance of R square.
Yeah, it's just here. Man has given the just definition of capital R square. That's it. No, it's not. We are discussing the depth about this capital R square. It's just what is R square. That's it. Capital R square. Okay. It's not. We have to consider the. I mean, we are not going to read about capital R square in depth. Here, just a definition of capital R square.
He has only
Okay.
explained that
Yeah, yeah.
in the
What is the
measure of
capital R square? Yes,
goodness,
yes, 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 yes.
there is
That's it.
nothing about calculation, sir, right?
No, 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 not at all. Not in this station course is only in this lecture there is a definition of capital R square. What is your capital R square? It's the goodness of fit test. That's it. No need. I mean, we are not going to read in depth what is the capital R square, what is the use and all things. Here just a definition. Okay, any doubt in this, or we can move for the next activity?
Sir,
Hello, we can,
ma'am
yeah,
said
we
that
can move.
capital R square is almost equal to small r square.
Yeah, it's kind of in terms of range.
So if somewhere asked that capital R square and small r square are equivalent,
Mhm.
that
Then you
this
can say,
statement will be true.
yeah, yeah. That's why ma'am said small r square is capital square. If it doesn't not true, then how can?
Sir, in my notes I have written approximately. So that it equivalent or they are approximate value.
Sorry?
When I make the note of this lecture, I
Hmm.
have written approximate as r tends to 1 or minus 1, then capital R square is approximately equal to small r square. Ma'am, so
Okay.
by the calculation.
Hmm.
So if somewhere mentioning in true false that they are equivalent, means whether we say capital R square or small r square, the value will always be same.
Mm-hmm.
Does this statement is correct, or they are not equivalent but value are somewhat match, means not exactly but they are near.
Okay, so what do you think about this?
Sir, I have no idea because the a capital R square is not discussed in detail
Yeah.
quantitatively.
So yeah, anybody, any one of you wants to explain where at which time it is? Can you tell me the time? I think I have to watch. I have to
Sir,
confirm this one.
probably uh, ma'am was showing a graph and he shows the capital R square and small r square value.
Okay,
Yes, sir.
small r
Yes,
is
sir.
yeah,
Is capital R
small
is
r
0.022.
022, small r is 0.149.
Yes, ma'am. Ma'am told that if you notice here that if you square the small r, then that is also
Yeah, that
approximate.
is the and range will also be 0 to 1,
Yes,
right?
yes, sir.
Small r is square. Okay, Ritik, I will check it is approximately or not. I think it should be, you can't, I mean, okay, I will check this in the lecture, okay, whether what is the correct statement. Okay,
Okay,
I
sir.
will let you know. So yeah, any doubt in this activity 4.9? What is the point biserial correlation coefficient?
It's a
Yes,
measure.
Option
It's a
C.
measure of association between numerical and categorical variable.
C option.
Okay, why not the D option?
Because sir, it is for r square.
Yes, correct, correct. It is for R because see between the explanatory variable and response variable is what? Nothing but the X and Y, and
Yes,
both
sir.
are numerical. See,
Numerical.
let me go through the. Suppose we want to know the whether two as two categorical variables are associated or not, then which method I have to use?
Conjunction table.
Contingency table.
Contingency table.
Contingency table.
Okay, we can find the row relative frequency or column relative frequency in contingency table.
Yes, sir.
Okay, so tell me if all the row relative frequencies are same for all the rows, then variables are associated or not?
Not associated.
Not associated.
Not
Not
associated.
associated.
Yes, sir.
Okay,
Variables are not associated.
if row relative frequencies are not same for all the rows, then variables are
Associated.
Associated.
okay.
Associated.
Suppose any question will come in the exam, then we you people will be able to solve this.
Yes. Yes, sir.
Okay, yeah.
Yes.
Sir,
So two
it is enough to check any one row relative
anyone,
or
yes, yes,
column,
correct, correct. Yeah,
not both.
anyone. If you are trusted to calculate the column relative frequency, then just go with the column relative frequency. I mean, you can use either one. Either you can use row relative frequency or column relative frequency. You have to just check.
There is no need to waste
Yeah,
time on
no, no,
calculating both.
no, 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 no. So association between two categorical variables we can find by the contingency table by computing row relative frequency or column
Yeah.
relative frequency, right? So yeah. So first of all, tell me. Suppose I want. Okay. Uh, gender is a categorical variable.
Yes.
Yes, sir.
Okay. Like suppose there are some. There are two categories, boys and girls. Okay. And this is the one categorical variable. Second categorical variable can be whether they are interested in mathematics or not. So second variable will be interest. Okay, so the two parts can be he is interested or not interested, right? So it can be like tell me the whether gender is associated with the interest in mathematics or not. Okay, I mean there might be some data and all thing. So you will be able to solve, I mean find the association between two categorical variables, right? Is it okay?
Yeah.
Yes,
Okay,
yes.
now so association between two numerical variables, okay, how we can find? By the correlation
and covariance.
coefficient, which is r, which is nothing but the covariance between x comma y divided by sx into sy, or you can say summation of xi minus x bar yi minus y bar divided by square root of summation xi minus x bar square divided by square root of yi minus y bar square. So this is, see what I'm trying to say here. What can be the two numerical variables like age, weight? Suppose this is x, this is y, right? Suppose I'm saying weight and the height. Okay, so numerical variables will be such kind of that. I mean, you can find the association of two categorical variables by the contingency table by computing row relative frequency or column relative frequency, and association between two numerical variables you can find by the correlation coefficient. Okay, and limits of correlation coefficient is -1 to 1, and there are some criteria. What is the strength of the correlations? You can find it by this. Now come to the point. We know how we can compute the association between two categorical, association between two numerical. Now the last point is how we can proceed for association between one categorical variable and one numerical variable, right? Okay, how we can find? Point by,
Point by serial.
so this is not denoted RPB, and it is nothing but the, suppose I am taking the absolute value, okay, divided by sigma x into square root of what?
P0 into P1.
P0 into
P1.
okay, and be careful, it will be population standard deviation. Okay, the lecture video there is some mistake, but it should be population standard deviation. Okay,
And
and
could you
what is the
please
P naught? N naught by N, I mean ratio of the first category, and P1 is the ratio of the second category. Okay, sigma x, you know what is the population standard deviation. Is it clear?
always population?
Yes, yes. It's the population. If you are using this formula, then you have to use the population standard deviation. Sample standard deviation you can use, but formula will get changed. By how? Let me tell you. You
And
know
some P
this,
naught P1 will also be.
yeah, will also be changed. I'm going to explain everything. Let me complete. You know this relationship. Are you aware about this relationship? All of you?
No, sir.
Are,
Standard
no?
deviation.
See, you know what is the s square is nothing but 1 upon n minus 1 summation of xi minus x bar square, right?
Right,
Yes,
sir.
Sigma
sir.
square, you know 1 upon n summation of xi minus x bar square.
Variance.
So here I can write n minus 1 times of s square equal to summation of xi minus x bar square. So similarly, if you
Yes,
multiplied by n, so I can write n sigma square is equal to summation of xi minus x bar square, right? So
yes,
this
yes.
right hand side are equal, then left hand side can also be equal or not?
Of course, sir. Of course, sir. We
Yes, sir.
understand.
Suppose x equal to
You
a
have just
and x equal
equivalent
to
the
b, that means
summation
a
of
equal to b.
xi and x bar square.
Okay, suppose x equal to a, x equal to b, then that means a equal to b, right? So from here I can write sigma square as n minus 1 divided by n into s square. So sigma will be square root of n minus 1 divided by n into s. So just replace this quantity. You will get y bar naught minus y bar 1 divided by square root of n minus 1 by n into s square root of p naught by p1. You can use this. Okay, see P naught and P1 is the same. It's P naught is same as N naught by N, and P1 is the same as N1 by N. So if you are using the standard deviation, sample standard deviation, then you have to use this formula. Okay, otherwise just for simplicity, just use the population standard deviation. Okay, and to be careful, I mean it is absolute point by serial. Okay, you people are aware how you can compute the this point by serial, or should I explain with any example?
Excuse me, sir.
Yes.
Sir, we do not do the sample correction over there that P naught is equal to N naught by N minus 1 or N1 P1 is equal to.
No, it's the
Sir,
same.
sigma is variance, no?
What variance? Sigma is the population standard deviation. Sigma
Okay.
square is the population variance. Okay.
Okay, sir.
See,
Yes, sir.
yes. If you replace the quantity here, okay. See,
Yes, sir.
I got it. What you are trying to say? Suppose this is what square root of n naught into n divided by n, right?
Yes, sir.
So, 1 second. This is y bar naught minus y bar 1 divided by sx into square root of p naught into p1. This is divided by square root of n minus n, right? So if you go by here, so you can write p naught into p1 into square root of n by n minus 1. Some,
Got it, sir. Got it, sir.
are you getting my point now?
Yes, sir. And that n cancel out and P naught by N minus 1 becomes left.
Yes. So just use the population standard deviation. It will be simple for you guys. Okay.
Yes, sir.
I'm just okay. So I'm just giving a simple example. Or should I give the example, or you are aware about how you can compute?
For example,
Okay, let me give. Suppose there is a variable gender. Okay,
Hmm.
and I'm considering the marks of. Suppose this is female. This is suppose 92, male 90, male 82, 32. Okay. And then suppose this is 72 and male. Okay. Suppose a question is asking, is there any association or is gender is associated with marks? So here gender is a categorical variable, right? You need to identify which one is categorical or numerical, and marks is the numerical. This thing is clear, right?
Sir.
So here it is asking about association between gender and marks. That means association between one categorical variable and one numerical variable. Okay, that means I need to find the I need to use the point by serial correlation coefficient, right? So in point by serial correlation coefficient, I can code a category as any category by 0. So here I am coding the female as 0. Okay, and next day male as 1. Okay, is it clear now till so far
Yes,
for
sir.
everyone? Yeah.
Yes, sir. Yes.
So what in the formula, what is the formula? RPV is nothing but this one. Okay, divided by sigma x into square root of p naught into p1. So p naught is what? N naught by n. Okay, so what is the n naught is here? 3. Number of you can say count of the observation which coded by 0. So 1, 2, 3, right? So 3 by 6. So total observation is how many? 3, or sorry, 6. See, n is 6. Out of these 6, n naught is 3. Count of
zero.
observation which coded by zeros. So it will be 1 by 2. So what is the P1? N1 by n, right? So n is 6. So what is the n1? This 1, 1 and 1. That
3.
means 3 by 6, which is 1 by 2. Here we have computed P0 and P1. Now we need to compute y bar naught. So what is the y bar naught? Anyone of
Sir,
you?
wait, wait,
65.33.
wait, sir.
Mhm.
P naught will be always n naught by n, whether it is saying population or sample.
See, why are you going to confuse in population sample?
Sir, ma'am has used SX properly.
That's why I said there is a mistake. We had a discussion with the ma'am. That is the mistake. We need to use the population standard deviation. In tutorial, we have used the population standard deviation, right? That's why I'm saying you have to use this population standard deviation. Okay, Ritik?
Okay, sir. Okay.
Yeah. This P naught and P1 is nothing but the, you can say proportion. What is the proportion of zero coded thing out of n? So out of n is what? Out, how many observation we have in total? 6, right? Out of these 6, how many observation we have which is coded by 0, 1, 2, and 3, right? Which is 3 by 6. Similarly for P1, 3 by 6. Till this point, any doubt?
No, sir, it's clear.
No, sir.
Okay. Yeah. So please tell me what is the y bar naught?
Sir,
65.33.
sir,
Sorry?
the mean of the categorical variable which one we have coded 0.
Correct. That means, see, y bar naught. That means this, things, and these things. Okay. So that means 92 plus 32 plus 72 by what?
Three.
By
Three.
3. Correct. Yeah. Most of the times, people make mistake. They divided by 6 simply. But no, we are computing the average of only these 3 observations here, right? So 92 plus 32 plus 72 divided by 3. Is it clear?
Yes, sir.
Yes, sir.
Suppose whatever value you will get, okay? Suppose,
65.33.
is it correct? I mean, I'm not going to compute. Suppose, yeah, this is the correct. And so suppose tell me what is the y bar 1?
So the mean of the boys' marks, and
Mean
it is
of the
found out to be
this
87.
observation for this 82 and this, okay, for 1. So that
Yes.
means 90 plus 82 plus 89 divided by,
3.
okay, is it clear?
Yes, sir.
So
Yes,
what
sir.
value you will get?
87.
Okay,
87.
87. Okay, yeah. So here we have computed y bar naught, we have computed y bar 1, we computed P naught, P1. The next thing we have to compute the sigma x. So what is the sigma x? How will you compute? So sigma x is what? X means, meaning of x is population standard deviation of the numerical variable, because the population standard deviation you can calculate for only for the numerical variable, right? So that means we need to compute the population standard deviation of this data set, this marks. So just compute the population standard deviation for this marks, whatever suppose I'm getting as let's say 4 point something, 4.3. I'm assuming, I'm not saying this is the correct. I mean, I'm assuming, suppose this is the 4.3. So point by serial correlation coefficient will be, see, you can, in the question I'm saying absolute point by serial, okay? But suppose it's not absolute point by serial, then try to take code the 0, that observation which is in I mean which is greater, right? Are you getting my point?
No,
So
Sir, can you
sir.
repeat that once
Will you
again?
please repeat?
I'm saying, see here, I'm going to compute the point, absolute point by serial, then calculation will I mean value will automatically will come in the positive value, right? I'm saying, suppose you are not going to compute the absolute point by serial, you are
Okay, sir.
just
We
going to
we
y
have
bar
got
not y
you.
minus. So just
Are
try
you,
to take 0, 1, that which comes in which comes greater, um, which will come in the greater.
sir? You
Are you
want to
getting?
remove the modulus sign, right?
Yeah, yes, that's what I'm saying. Suppose it's not saying about absolute point by serial, it's some simple things. Just compute the point by serial, then try to code 0 those observations which are in which value is greater than y bar 1. Are you getting?
Yes, sir, we are getting. And
Yeah.
sir, this deviation will be square root of summation of xi minus x bar whole square divided by 6, right, sir? Where xi
Yes,
will be
correct,
marks.
correct, 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 correct. This will be the this. Correct. So this will be, suppose see, by hypothetically I'm assuming, suppose this is 4.3 and you know P naught is 1 by 2 and 1 by 2. So just compute it, you will get you. So is it clear how will you compute the y bar naught, y bar 1, P naught, P1, right?
Yeah. Yes.
Okay. Any doubt in this?
Sir, ma'am, I use the term correlational coefficient. So is there difference between correlation and correlation coefficient?
No, no. That means see, R is correlation coefficient. I mean, to find the correlation between, using that, yeah, this is the correlation coefficient for this. This is the, you can simply say, what is the correlation between these two? What is the correlation value of correlation coefficient between
Sir,
these two?
correlation has been also used previously to find two numerical variable. So is
That is the
that the
correlation
correlation?
coefficient, and this see, that is the correlation. See, here you are finding the correlation between one categorical variable and numerical variable, right? If the see, if you have to find the correlation between two numerical variable, then you have to use the small r. If you have to find the correlation or association between one categorical and one numerical, then you have to use the point biserial. Okay.
And to denote the point by serial, we are putting a
You can
subscript
say
RB, a
RPB.
PB.
Yeah, yeah. Is it clear for everyone?
Yes, sir.
Sir, is it possible that we have given two numerical variable and one categorical and numerical variable, and since the name matches correlation coefficient and correlation, so is it possible the question might come that which has more, means comparison between a categorical and numerical and other data
Ah,
both numerical.
it depends, Ritik. In our exams, we'll give the questions only related and based on the topics or syllabus which are covered in this foundational level course. Okay, no need to worry about the extra things and all things. Okay, and rest of
Okay,
the
sir.
things which you are expecting in advance, like say some people, some of you have doubt why you are using the n minus one in sample variance on 1 by n population variance, such kind of things you will yesterday in the stage 2, I mean in the advanced course. Here just a basic idea about the things. Okay, so that you are aware about the, you are familiar with the terms and rest of the terminology and concept and all this. Okay. So any one of you
Okay,
have
sir.
doubt in
And sir, my
practices
last
and
question is, sir, actually I have joined little late.
mm-hmm.
1 hour lecture I have missed, sir.
Mm-hmm.
So I wanted, is there other mistake just like this in correlation coefficient, ma'am has
No, 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 no,
written Sx? Is there
no, no, no,
other mistake in lecture?
no, 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 not. That
Okay,
is the,
sir. In three.
that is not the
Okay, sir.
mistake. You can say ma'am has used, I think P naught by N1 also ma'am has used. Okay, just try to watch. For now, you can use this population standard deviation. Okay, and you want to use the sample standard deviation, then formula will get changed by this. Okay.
Okay, sir.
So yeah.
Hello.
Anything else? Anybody?
Yes, sir. Hello.
Yeah. Yes, please. Yeah. Yeah. Yes, Prachi.
Um, sir, where we have to find correlation coefficient between two numerical variables, and where we have to find correlation coefficient between numerical and categorical variables. The question is clearly given, or we have to understand by ourselves.
No, no. Question will be clearly given. If it's not, see, things will be clearly mentioned in the question. If it's not, then see, it's a simple things for you how to identify whether it is categorical variables or a numerical variable, right? So it's
So we
given to you, right? Suppose two categorical variable will be given, so you have to find you have to question will be like association between gender and I took the example of interest in mathematics. So gender is a categorical variable, interest in mathematics is also categorical variable, right? So numerical variable will be like suppose weight and age. So we can ask what is the correlation coefficient between weight and age or height and weight or something else, right? So height and weight you can say. So height and weight it's a numerical variable and we are asking correlation coefficient. That means you have to use the small r, right? If it's one categorical and one numerical, then it will be find the what is the point biserial correlation between these two. Like I took the example of gender and marks.
Okay,
Is it
sir.
clear, Prachi?
Some means sometimes there is mention to find the point by
Yeah,
serial.
yeah, see.
Or
Yes, yes. And you to just see, you are able to identify which one is the categorical or which one is the numerical, right? And in
yes,
the
sir.
question,
There is
suppose
no
what,
need
see,
because if
see,
categorical data is there, then we cannot find normal correlation.
suppose in the question, one variable is given to you like categories, like one variable is gender, female, male, male, female, or yes, no kind of things, one variable, right? Second variable is numerical, and it is asking about the what is the correlation coefficient, or then you have to find the point by serial, right? Because one is the categorical, one is the numerical.
Okay, sir.
Okay, you can't find the small r because for the small r you need to find the covariance between x and y, which is 1 upon n summation xi minus x bar into yi minus y bar. So you cannot compute x bar for a categorical variable, right?
Okay, sir.
See, for the in this foundational level course, things will be clearly mentioned. No need to worry about that. If it's not, then you are aware how to identify the categorical variable, how to identify the numerical variable. No need to worry about that. Okay.
Okay, sir. And
Oh,
sir, one thing more. In a
yes, yes.
correlation, the range is given. So we get the answer always in this range.
Yes, yes. That's why its the range is given. Correlation coefficient is always lies between -1 to 1.
Okay, sir.
But
Because
is
Okay.
there
sometimes,
And
range of correlation biserial coefficient also?
I have written this I mean, some criteria to identify whether is strong and positive, moderate and positive, weak and positive. In this case, there is no linear relationship. In this case, weak and negative. In this case, moderate and negative. In this case, it will be strong and negative. Okay. So you can take the screenshot from here for your simplicity and for the file.
okay. Because
Okay.
sometimes we get answer more than this range. That's why.
No, no, you can't. See, if you are getting the value of R more than 1 or less than -1, that means you are doing some mistake. You need to check very carefully.
Okay, sir.
Okay? Yeah.
Okay, sir.
But is there range of biserial correlation coefficient
Yeah,
also?
it's a simple range. Yeah, there is something, if it lies between 0. Uh, absolute value of if it lies between 0.75 to 1, that means I mean there is the variable is strongly influenced or strongly related, otherwise there is they are not strongly related, right? So strongly influenced or you can say strongly related, you can say. Okay, if it's not, then is not strongly related, that's it. Okay.
Sir, but why you need to put a mod on biserial? It is always positive because square root, sigma, and mod.
Okay, okay. You are saying it's always positive. Just take this example. Y bar naught is 65.33 and Y bar 1 is 87. Then will it be negative or not?
Sir, if you put modulus and then how it will be
Yeah,
negative?
see, what is the meaning of putting modulus here? It means if you are computing the absolute value of point by serial, that's it. It's not about, see, RPB is like, see, in general formula is RPB is y bar naught minus y bar 1. Okay.
Okay, sir. Actually, ma'am, I put at the mods
No, no, no.
already. Oh, no,
See,
no,
it's
no. Yes, sir, yes, sir, right.
this, yeah. This formula is formula of absolute point biserial. Okay.
Okay, sir.
Correct. Yeah. Okay.
And
Anything else?
if it is
Anybody?
coming out to be negative, we have to report the positive one only.
Yes. Report the positive one means just tell, I mean, code the value 0. That, I mean, see, one second, let me. Yeah. Suppose here, suppose I'm computing just a simple point biserial. Okay. Then my values will come in the negative. Okay. So
Yes, sir.
in that case, try to code 0 those values which are in positive, right? That means I can also, I can we can also code the male as 0, right?
Yes, sir.
Just code the male as 0 and female as, then you will get the value in positive, right?
Okay,
Is it
sir.
clear? Is it clear?
Yes, sir. It's clear, sir.
Okay. Okay. Anybody, anything else? Any doubt in week 4 activity practice or any concept?
Hello.
Yes, yes.
Sir, correlation can also be dependent on R square.
It's not kind of a dependency. What ma'am has told, small r square is equal to capital R square. Okay.
Yes, sir.
So here just ma'am give the basic idea. That means capital R square is equal to the small r square. That's it. We are not going to read in the depth about capital R square and how to compute capital R square and all things. It's just a basic idea. Capital R square is same as the small r square. Okay.
Okay, sir.
Yeah.
Okay, sir.
Yeah. So anything
And sir,
else? Anybody?
covariance calculation will come, but its interpretation will not come, sir. Right, sir?
Interpretation will not come. Means?
Covariance in
Did not get your question actually.
actually, ma'am, I told no, it is difficult to interpret covariance.
Yes, difficult to interpret a covariance means value of covariance comes out in the units, right?
Yes, sir.
So, but correlation coefficient gives you unitless measure. That's why correlation coefficient is easy
So,
to interpret. That's the things. That's why.
so if there are two covariance value, the higher one will be better one, right, sir?
Higher one will be better one.
If there are covariance 50 and 100,
Hmm.
100 will be better data, a better association.
Okay. How can you interpret that? That's why correlation coefficient comes into the picture.
Okay, means we will
Suppose
only be
for any
given.
data set, you are getting covariance as 250, and for a data set, you are getting the covariance as 72. Then
Yes,
how
sir.
can you interpret? How will you interpret that? I mean, strength of linear relationship. I mean, there is no such things for saying, yeah, this things is better than these things, right? How can you say, yeah, see, you do not know the limit. You can't say like 250 is better.
So only the
You can't
sign
say
matters,
7.
sir, right?
See, listen to me. Let me finish first. You are also, you can't say 72 is less, right?
Right, sir.
That's
Yes,
why,
sir.
and it gives you the things in units also. Let's say year into year and kilogram, right?
Yes,
Suppose
sir.
data is about age and, but correlation coefficient gives you unitless measure. First thing, and
Yes, sir.
R is lies between -1 and 1. Suppose R is 0.89, then you can say easily say there is a strong and positive linear relationship between these two categorical between these two numerical variables, right?
Right, sir.
So that's why correlation coefficient comes into the picture. Is
Okay,
it
sir.
clear?
Means, interpretation of covariance
Yes,
will be
yes.
only positive negative, right?
Yeah, it's a positive negative. Yeah, covariance is positive, covariance negative. I mean, you
If
can't say exactly, yeah, this is the less, this is the greater.
okay,
Suppose
we
for
can
any
only
data set
say
you
that.
got the covariance -2, then
Yes, sir.
I mean, how you can say like it's a better or it's a less or something else, right? You can say, yeah, positive correlation up on negative covariance. Okay, is it
Okay,
clear?
sir. Yes, sir.
Okay, anything else, anybody?
So, just for 1 minute, you can open the graded assignment 4.
Graded assignment 4.
Yes, sir.
Okay, so okay, what is your
Question
doubt?
number, question number second.
Okay,
I mean,
yes,
no, sir. Scroll it. I mean, second table.
okay.
In this, some data is missing, sir.
No, why data is missing? I mean, why do you feel?
I mean, in this question, the first question of this, are you able to see all the 8 values in the
See,
contingency table?
okay. This question is, see, suppose this question we have mentioned because it's sometimes due to some portal issue and all things. Suppose some data is missed. Okay, so it's just a cross check. Are you able to see the 8 values? Then it's okay. Okay, then proceed. Suppose due to some portal issue and all things, only 6 values is I mean available for you. Then you cannot find the rest of the question
Sir,
calculation
what
for
is
the
the
rest
meaning
of the
of zero
question.
points over
Oh, so
here?
that's why 0
That means,
points are given,
see,
right,
that's
sir?
why it's a 0 point. 0 point means there is no graded. It's just for cross check. Like you are able to see the values. Yeah, if you are able to see, yeah, just it's a cross check. You can say yes or I mean it's a you can type 0 or 1. Then you can see.
Sir, we can
I
also
mean,
leave it
what is the
blank
meaning of?
also. It will not
Yeah,
affect.
it's no. Yeah, no, it will not affect. No, it will not
Sir, means such type of thing will also come in quiz.
No, no, not in the quiz. The quiz, only concept related things. Is it clear, Prachi, now? The same things is for question 1 also, for table 1. Are you able to see 7 dealers, location and sales of one thing? Vivek, is it clear now?
Yes, sir. This one is clear, but in the second one, no, something is not clear. Yeah, it's in the uh, column of a dull.
Mhm.
Something is written 8 or I think 8-4 or 8-7.
84 and 87?
Yeah,
84 and 87.
84. Yeah, 84, 87. I don't know what
So,
is written.
okay, you are not able to see that one. Okay, you are saying.
Yes, sir.
Okay, it's see things very values are changed. No, you are now. I mean, you are not able to see on my screen or for you.
In my graded
Okay,
assignment.
okay. So okay. Just take the screenshot and post on the discussion forum. We'll check that. Okay,
Okay, sir.
or you can try to see. I mean, visualize by zoom in. Okay.
Okay, sir. I'll try.
Yeah, try if you are not. I mean, if you are able to, if you are not able to do, just post on the we'll check.
Some line is coming.
Okay. Yeah, we'll check. We'll check. Just post on the discussion of this. Okay.
Okay, sir. I'll
She
try.
might be using in phone, sir. See, you should
Yeah, it might be. Yeah, but you are using on phone or laptop. Yeah, this things also.
Sir,
This might be.
phone.
click
Okay,
on
just
desktop mode. On Chrome,
Okay.
there will be desktop mode.
yes,
Click on
yes,
three
yes.
dot
Correct,
icon and you will get desktop mode.
correct.
Okay.
Then you will be able to see the values in the clear way.
And put your phone on landscape. If you'll rotate, the viewing style
Mm-hmm.
might change.
Then yeah, things will be bigger.
Okay, sir.
Rotate your device on landscape.
Because after the dull, your table is clearly visible, but in my case,
Yeah,
it's
yeah.
not
That's
visible.
yeah. Ritik is saying correct because it's some just put your phone on landscape mode and convert in desktop mode so that you can see the thing values in bigger, I mean big size rather than.
Okay, sir.
Okay. Yeah, yeah.
Yeah. Okay.
Okay,
Thank you, sir.
anything else? Yeah, thanks. Anything else, anybody? You can
No, sir.
ask. So if you have any doubt, any concept related doubt, anything else, so you can ask in any activity, any practice. Otherwise, if not, then we can close the session.
I have a doubt, but not the subject related.
Okay,
For
yeah.
qualifier 1 to 4 week only will take for preference, right?
Yeah. In the qualifier exam, syllabus will be only from week 1 to week 4.
Okay.
But graded assignment was considered only week 1 to 3, right, sir?
Yes, you can check from the grading pattern, something based
Yes, sir.
2 out of
There
3
we
was
are
something.
getting email only up
Mhm.
to 3 graded.
Yeah, it was something based 2 out of 3, right? There are some criteria. That's why we were saying just go through the grading pattern. Okay. Oh yeah. So in qualifier, syllabus will be from week 1 to week. Okay.
Thank you, sir.
So
Thank you,
how
sir.
so how we will know that we are eligible for qualifier or not?
Yeah, supporting will tell you. If you yeah, that's why again
Sir,
I
we have
say.
got it the message our exam city on latest update.
Yeah, see, everyone will get the notification. Just go for I mean here general instruction and important links. You will get the things. Click here to view the grading document. In this, you will get whole I mean whole information. What is I mean less than 40, greater than 40, all things you will get. Okay, just go through this grading document. Okay.
Sir, I have somewhere seen that the examination hall ticket will be released on 10 or 11 October. Somewhere
Yeah,
it was mentioned.
see, such these type of things will be done. No need to worry about this. This type of things will be done by the support team. Okay, no need to worry about where when it will come, when it will not. Okay, anything else? Anybody? Any concept related doubt? Any activity? Any practice from week 4 and all things? So you can ask.
Sir,
Otherwise,
not basically from week 4, but just a general doubt in from week 5. Sir, are if there are two number plates of a car and
Yeah,
it is 047 and 0473 and the second one is 473, are these two card numbers different or they are equivalent or the same?
okay. So you are talking about number plate. Okay.
Yes, sir. And if
This
they
is
are,
also from a graded one.
yes.
Okay, see, Avinash, what is the thing? Try to think. See, suppose my car number is let's say 047 3 or something else. Okay,
Yes, sir.
and your car number plate is 0472. Okay,
Yes, sir.
so both the things are same or different?
Sir, uh, I'm just talking about if zero precedes the number, whether.
No. That's why I take the example of 0. Suppose my car number plate is 0472. Okay, and your
Yes,
car
sir.
number plate is 0473. So is this same or different?
Different, sir.
So
Sir,
just think like that.
one car
Okay.
is your and other car is her, sir.
Okay.
So both
So
car are
that's it.
different.
I mean, just try to think like that. Okay.
Yes,
Yeah.
sir.
Okay. Yeah.
Mm.
Okay.
Sir,
Anything else?
when book will
Anybody?
come, sir?
Sorry.
Books, sir. You have told statics books will are coming soon. PDF, statics book PDF.
Okay. Textbook, right?
Yes, sir. Textbook.
Yeah. We'll update. We'll update. It's under progress. We'll update soon. Okay. No need to. When it will be updated, you will get the information about related that. Okay. Okay. Anything else? Anybody? So So we can discuss otherwise. Hello.
No doubt, sir. All clear.
Okay, all clear. Okay, then. Thanks everyone.
Thank you very much,
Hope
sir.
all of
Thank you, sir.
Thank
your
you,
all
sir.
doubts are cleared.
Thank you, sir.
Okay.
Good night, sir.
Thank you, sir.
Yeah.
Thank
Thanks.
you so
Thanks.
much, sir. Good night. Good night.
Good night, sir.
Good
Good
night,
night.
sir. Good night.
Good night. Good night. I'm hoping all your
Good
doubts are
night,
cleared.
sir.
Oh, okay. Good night. Good night.
Bye, sir.
Good night,
Bye
sir.
bye.
KL
Bye
राहुल को
everyone.
पेड़ चढ़ाया जाता
Good night, sir.